Good morning, students. The last class we saw about the concept of depth limited search. So why we go for depth limited search? The main reason for going for depth limited search is that, so in a depth first search, what will happen? You need to traverse till the last depth. Suppose you have a tree of having 100 levels and your goal set is somewhere in the right hand side, somewhere over here like this. So you have a tree here. I have got it only level 3, but if you think that you have 100 levels and you have the goal state somewhere in the level 10 itself, so what will happen? You need to traverse from the root node till the level 100. Again I should come up, I should go traverse till the level 100. So I should be traveling like this. So it will take lot of time to reach the right hand side part. Though your goal state is in the level 10 itself, I need to traverse till the level 100. So this is the main disadvantage of depth first search. If your goal state is somewhere in the right hand side and you have more number of levels. Okay, if the depth is high and your goal set is in the right hand side, this is the problem. Suppose if your goal set is somewhere in the left hand side itself, so very easily when you traverse, you reach this node. If it is the same goal state, if you have it in level 10 on the left hand side part and you traverse over here, what will happen? You can easily reach the goal state. So this type of scenarios where your goal state is in the right hand side in a tree that has more number of levels, what will happen? The depth first search becomes a disadvantage because of what? If the time complexity is also high, your space complexity also naturally becomes high. So in that case, what will happen? We are predefining the depth we saw in the last class. So there is a main reason we are going for depth limited search. Now, so we saw the advantages and disadvantages. The disadvantages was it is incomplete. I'll show it has a disadvantage of incomplete. When it becomes incomplete, okay, when it becomes incomplete. Suppose you are your the goal set is somewhere in the level 10, okay, and you had your depth limit as level 8 itself. I repeat once again, you have your goal state in your 10th level, and you have reached you defined the depth limit as 8 itself. What will happen? From the root node, you will traverse till the 8th level. You will be traversing and come to the right hand side. You will not reach the goal state at all because your goal state is present in your 10th level. So what will happen in that case? It becomes incomplete. Okay, so that's the point they are told over here. Then it will not be optimal if L is greater than or equal to D. What is L and what is D? L is nothing but predefined limit. D is nothing but the depth in which your goal state is present. So totally we have 100 levels. Okay, your goal state is present at the 10th level. Consider D equal to 10. So consider L value as, if it is 12, okay, it's well and good. If it is 12, at least you can reach, you are going to traverse at least only 2 levels. Suppose in the same tree, if you have 100 levels and you have the L values predefined length as 88, something like that, consider you have it as 90. Then what you have to do? But your D is nothing but the depth in which your goal state is present. Your goal state is present in the 10th level itself, but you have defined the predefined depth limit value as 90. Then what will happen? From the root node, you need to travel till the 90th level, come up again, travel till the 90th level, come up, and finally you will reach the goal state which is present in the level 10 itself. So if your depth limit should not be more high, okay, always if what will happen? Your depth limit should be at least 2 levels or 1 level earlier itself. Okay, suppose you have your goal state as in level 10 itself, you can have your depth limit as 12 or 15, something which is closer. If you have more difference, if you have 90, 95, then your time complexity becomes high. If it is less than that, your goal state is in level 10, but you have a depth limit as 8, then you will not reach the goal state itself. In that case, it becomes incomplete. So naturally how your depth limit should be? It can be closer to your goal state level. It should not be more. There should not be more difference. If it's having more difference, then your time complexity is high. So this is the main disadvantage. Now we shall see about the codes. Codes is nothing but your completeness, optimality, time complexity, and space complexity. So your first letters of these terminologies is taken and considered as codes. So for each search we need to conclude with this codes, whether how far it is the search is complete, how far it is optimal, and how far they have the time complexity and space complexity. First one, it's complete. This depth search is complete only if the depth limit is greater than or equal to d. D is nothing but once again the depth where the goal state lies or where the solution lies. Suppose you have a depth as 10. Your L is 12. 12 is greater than 10? Yes, 12 is greater than 10. So it is complete. So certainly you will reach the goal state. Since you will be traversing till the 12th level, you will be traversing, your goal state is somewhere in level 10. You have your depth limit as 12. So what will happen? You will be traversing till the level 12, come up, level 12, come up, level 10, come up. You will finally reach the goal state at 10. Okay. Suppose if it is less than, which I discussed earlier itself, if it is less than, so D is 10 and your L is 8, then what will happen? It is incomplete. We already saw that as a disadvantage. So when it is becoming complete, when L value is greater than or equal to D, and it should not be too high, that also we saw. Then when it is incomplete, when L value is less than D. Now coming to the next one, optimality. So whether this depth limited search can be viewed as optimal, some cases it will not be considered optimal, because if L value is greater than D, that also we saw now, L value can be quite higher, that's it. If D is equal to 10, the depth in which the goal state is present is if it is 10, and if your L value is somewhere little higher, greater than D, suppose if it is 12, then it will be quite optimal. But if it is 90, then what will happen? It will take more time, more space to reach the goal state. So it should not be what happened? It should not be more higher value than your D value. D is nothing but the depth in which your goal state is present. If it is more higher, then what will happen? Time complexity and space complexity is going to be high. Finally, it's not going to be an optimal solution. Okay. So how the time complexity and the space complexity is calculated? Time complexity of the depth limited search is order of B power L. B is nothing but the branching factor and L is your predefined depth. So what is the branching factor? So here the branching factor is how many number of children each node has. Here this node has 2 children, this node has 2 children, this node has 2 children. So the maximum number of children each node has is 2. So the branching factor is 2 in this case. Okay, so likewise time complexity is calculated. Space complexity, how it is calculated? Space complexity depth limited searches order of B into L. Earlier it was B power L for time complexity. Here in space complexity it is B into L. So in this way your depth limited search has all these 4 criteria. First one is completeness, optimality, third one is time complexity, space complexity. So if you want to easy to remember, you can have the acronym as codes: completeness, optimality, time complexity, and space complexity. The upcoming class will be learning about what do you mean by informed search, and we have you have best first search, nothing but your greedy search, and A star search. In next video we shall see about best first search, followed by you'll be seeing about A star search. Thank you so much.